There are many different ways to obtain weather information before a flight. The FAA maintains a nationwide network of automated flight service stations to serve the weather needs of pilots. An official weather briefing can be obtained by calling 1-800-WX-BRIEF. Another way is using an online system called DUOT, which stands for Direct User Access Terminal Service. This is a program funded by the FAA to allow any pilot to use a computer to access weather information or even file flight plans. There are two companies that provide this service, CSC, which is found at duots.com, or DTC, found at duot.com. Weather information can also be obtained from the Aviation Digital Data Service, or ADS. This is found at aviationweather.gov/ads. Make sure, no matter where you get your weather information, that on every product or image, you check the date and time it was published to make sure it's the most up-to-date information you can get. There are several types of weather products that pilots can use to make their go, no-go decision before a flight. Many of the weather products contain abbreviations and codes, which give pilots a lot of information in a little bit of space. If you need help decoding the reports, try checking out the latest copy of the FAA's Aviation Weather Services Advisory Circular from the FAA's website. Here is just a quick overview of some of the weather products. We'll start with weather products that tell us what is happening right now. The basic surface observation of weather conditions is called a METAR. A METAR is an hourly weather report that includes the airport identifier, time of observation, wind, visibility, runway visual range, present weather phenomena, sky conditions, temperature, dew point, and altimeter setting. There will also be some remarks added to the end of the report to give additional information. METARs are created once an hour, usually at 53 minutes after the hour. If the weather changes significantly, a special METAR called a SPECI is produced to make sure that pilots have the latest weather information. A PIREP, or pilot report, is a type of weather report made by pilots themselves, recording actual weather conditions that he or she is experiencing. Pilots should report any observation, good or bad, to assist other pilots with flight planning and preparation. If conditions were forecasted to occur, but not encountered, a pilot should also report this inaccuracy. There are two types of PIREPs, routine and urgent. The required elements for all PIREPs are the message type, location, time, altitude, type of aircraft making the report, and at least one other element describing the reported weather conditions. Some of the items that can be reported are the sky condition and cloud levels, flight visibility and weather, air temperature, winds aloft, turbulence level, icing conditions, or any other remarks the pilot wishes to add. There are several satellites in orbit around Earth that give us imagery of the clouds around the Earth. There are three types of imagery commonly used by pilots: visible, infrared, and water vapor. Each image is updated about every 15 minutes. Visible satellite images display reflected sunlight from the Earth's surface, clouds, and particulate matter in the atmosphere. It creates black and white images that are only useful during daylight hours. This image uses the highest resolution and approximate what it is seen with the human eye. You can even see features like snow and bodies of water. Infrared, IR, images display temperature of the Earth's surface, clouds, and particulate matter. The warmer an object is, the more infrared energy it emits. The satellite sensor measures this energy, and the higher something is in the atmosphere, the colder it is, while the lower something is in the atmosphere, the warmer it is. This information can then be displayed on a map either in color code or in black and white. The colors help enhance the image and make it easier to see the temperature changes. The water vapor imagery displays the quantity of water vapor in the air. This generally only measures water vapor located in the middle and upper troposphere between flight level 100 to flight level 390. Water vapor imagery does not really see clouds, but sees high-level water vapor instead. The water vapor imagery is very useful to see the motion of the upper atmosphere in features like fronts, highs, and lows, for example. Radar images are graphical displays of precipitation and non-precipitation targets detected by weather radar. Under the dome, a radar station is composed of a rotating dish that sends pulses of radio waves out into space. When the pulse hits a target, such as rain, airplanes, or any solid object, it is scattered in all directions, even continuing through the rain away from the radar. However, a small amount of energy does return back to the radar station. By determining the length of time it took for the signal to return to the dish, the amount of energy returned, in other words, its reflectivity, and position of the radar, computers can generate an image to display precipitation. Once a full 360-degree revolution is complete, the radar dish will tilt up and scan the area again. The station will do this a few times, which accounts for the delay in updated radar images. The radar is able to make different images to show different parameters of storms. The most common radar images are base reflectivity and composite reflectivity. Base reflectivity shows radar returns at the lowest radar scan level above the horizon. This image is useful for seeing the precipitation that is lower to the surface. Composite reflectivity shows the maximum echo intensity or reflectivity detected within a column of the atmosphere above a location. The station scans through all of the elevation slices to determine the highest value in the vertical column, then displays that value on the product. When compared with base reflectivity, the composite reflectivity can reveal important storm structure features and intensity trends of storms. The maximum range of single radar site is approximately 124 nautical miles. This means you may have to look at multiple radar sites to cover a longer flight. It's also a good idea to check out any available radar mosaics. A radar mosaic is an image composed of multiple single-site radar pictures on one map to get a larger scale view of where precipitation is falling. It's also always best to animate the images too. That way you can see trends of motion and if storms are building or deteriorating. Surface analysis charts are analyzed charts of surface weather observations. The chart shows sea level pressure in millibars, the position of highs, lows, the location and type of fronts, and other boundaries like dry lines, outflow boundaries, and the sea breeze. Freezing level graphics show where the temperature is below freezing and can give pilots an idea of where to possibly expect icing conditions. Be aware that there can be multiple freezing layers of air over a given point. This usually implies that different air masses are stacked on top of each other. These charts are issued hourly and are based off of computer models. Airman's Meteorological Information, or AirMet, is a concise description of the occurrence or expected occurrence of specified en route weather phenomena which may affect the safety of aircraft operations. AirMets are intended for dissemination to all pilots in flight to enhance safety and advise pilots of weather potentially hazardous to all aircraft, such as icing conditions, turbulence, or locations where there are IFR conditions or mountain obscuration. These AirMets are valid for 6 hours. Significant Meteorological Information, or SIGMET, is a weather advisory which is disseminated when weather phenomena which may affect the safety of aircraft operations is expected or occurring en route. SIGMETs are issued for conditions of severe or greater turbulence, severe icing, a widespread dust storm, or a widespread sandstorm. These SIGMETs are valid for 4 hours. For thunderstorm-related activity, convective SIGMETs are issued. These will be disseminated for such things as thunderstorms, lines of thunderstorms. In all AirMets, SIGMETs, and convective SIGMETs are shown on maps with boxes that show the different types of weather conditions and the altitudes that are affected. Now that we've taken a look at the most popular weather reports, let's look at some forecast products which help determine what the weather will be in the future. A Terminal Aerodrome Forecast, or TAF, is a forecast